Hey guys, so now that we already did our vertical and horizontal shifts, we're going to go into another type of transformations, and that's when we stretch our function vertically or horizontally. So on top of that, we're also going to talk about the reflections over the x-axis and the y-axis. So let's get started. So here we have that vertical or horizontal shifts are always done last. If you guys remember, I really stressed in the first video that we have to do the vertical shift last. So whenever we're going through all our shifts, and when they're all put together, the vertical shift must go last. And a quick reminder, it's on the outside, so that also helps us to know that it's going to go last. So next thing is, when we have a vertical stretch, or we're going to shorten VS, it makes the function skinnier or fatter. Okay, so let's talk about this, right? A vertical stretch should just be like when you're a little short fat kid, and then you become like taller when you grow up. You're going to kind of stretch the fat kid, and that means that if you stretch his fat, he becomes skinnier, right? So just think about the fat kid here, and when he gets taller, and we just stretch him. Then we're going to talk about a horizontal stretch, right? So let's get this, not like the fat kid, but we're going to get like your cheeks, and we're going to stretch them, right? So like girls and moms, they love to be like, oh, he's so cute. They grab your cheeks and they stretch them horizontally. That makes your cheeks and your whole face overall fatter. So that means that when we have a horizontal stretch, Greek cheek grab, we're going to call the function becoming fatter. Alright? So I hope that helped for the references that when you have a vertical shift, boom, skinny. When you have a horizontal stretch, boom, fat. Alright? So we're going to do this with our parabola. So we're going to have, in black, we're going to have our parabola. And then, if we grab our parabola and we stretch it, it's going to become skinnier. So the function is just going to be right on top of it, but it's going to be a lot skinnier, right? By a factor of c, whatever that factor is. So whenever we have a number outside right here multiplying, it's going to be a vertical stretch, or the function is going to become skinnier. So look out for the numbers. The numbers makes your function skinnier. And now when we have the fractions, we're going to see how it's going to affect our function. So now when we have a fraction, or 1 over a positive number, we're going to call that a vertical shrink. Now, if you think about it, a vertical shrink is going to be when you're going from, so a vertical stretch, you get taller, so you get skinnier, right? But a vertical shrink, you're taller, and now you're gonna shrink vertically, so you're gonna go boom. So like that means that now you're gonna be fatter. So if you have a vertical shrink or a fraction, fractions are fatter, FF. Let's make that reference. So we have a fraction, boom. We get skinnier, fatter. So now your parabola is just going to become fatter. Fraction, fatter. Alright, so now this is when we have numbers outside. When we have a number outside, it becomes skinnier. When we have a fraction outside, it becomes fatter. But how about when we have numbers inside your function, right? So in this case, we're going to have a fraction inside, and we're going to say that we have a horizontal stretch, right? So to show this, I'm going to use a different function. I'm going to use the radical function, or the penis function, I like to call it. So here we're going to draw a penis function, your radical function. And what we're going to do is we're going to horizontally stretch your penis, right? So we grab your penis and then we just kind of like stretch it horizontally. What's going to happen? It's going to be longer in a way. You're going to get a longer penis, but you're squeezing it, so it's going to get a little like skinnier, if you know what I mean. So we're going to grab your penis and we're going to stretch it. So what we're going to do, I'm sorry you don't have a penis, this does not apply to you, try it on somebody else. It's going to be like this. So you're actually going to go a little lower. It's going to stretch horizontally, so your penis is going to become longer but at a lower height. So it's going to go lower in height compared to its parent function, but longer. So that's what a horizontal stretch does. So now here we're going to have a horizontal shrink. So we're going to draw your penis again, okay? And what we're going to do is like, we're going to like push your penis away. So it's going to be like, no, I don't want penis. So penis is going to be pushed away. It's actually going to get like a little smaller in a way, but now it's going to be like fatter. So you're going from like long to a little shorter. So you're going like almost into a chode. If you don't know what a chode is, look it up. So now that I'm back, I'm going to draw what it would look like if I had a horizontal shrink, right? So if I grab my penis and I go boom, it's kind of going to be like, it's going to go higher because now I have less distance to cover. So that's how it would look. So now the function will land on top. So if you guys see here, now we have talked about when we have a fraction inside and when we have a number inside, what it's going to affect our function horizontally. So you guys will get used to these shifts when you guys are seeing some examples, which we do right after I introduce our reflections. Okay? So now let's talk about our reflections. So for our reflections, I'm still going to use the penis function. I love the penis function. It just kind of works very well. Well, that's an excited penis I just drew. It needs to be more of a calm penis. Like that, right? So now, when we have a negative outside, of our function, you see how the negative is outside, we're going to have a vertical reflection. What this means is that I'm going to have a reflection over the x-axis. So if my penis is like this, it's now going to reflect over the x-axis, so I'm going to go boom. Well, I can't do that with my hands, but penis not down here. There we go. Penis goes up, goes down. So we're going to have the penis reflect over the x-axis. We're going to reflect vertically. So our new penis is sad and it's down here. You know, everyone has his own shape and his own style to it. This is the vertical reflected penis. Now we're going to draw another function or another penis. And we're going to think about when we have a negative inside. So I like it in red better. So whenever we have our negative inside, what we're going to do is we're going to have a horizontal reflection. So horizontal means like a laying down reflection in a way, like over the x-axis. But what we're going to do is we're going to reflect it over the y-axis. So real quick, if it's outside, it's going to be over the x-axis. If it's inside, it's going to be over the y-axis. So if we reflect it over the y-axis, let's draw our y-axis, and now we just reflect it right over. We draw a reflection, and our penis is facing the other way. Alright? So now that we've introduced our horizontal stretches and our vertical stretches along with the shrinks, we're also going to go into our examples where we combined shifting up and down, shifting left and right, stretching, and reflection. So now there's a lot more to think about, but I must go over that. It's also very important to remember that the last thing we're going to do is going to be our vertical shift. It's always going to be our last thing. So here we're going to have an example 1, we're going to have a lot of stuff going on, but let's just keep it calm, right? The first thing we got to do when we look at our functions and we want to check out its transformation, we're going to ask ourselves, what is the parent function, right? So we look at example 1, we notice our x to the 3, and we know that x to the 3 is an odd number, so odd people are awkward, so we're just going to be like, boom, awkward. Alright? So we're going to draw in black to represent our parent function in black. Okay? So now we're going to talk about the different shifts and write them down and like see how this all gets affected, right? So let's scroll up a little, give ourselves a little more space. So we have our cubic function because we have a 3. And now let's talk about the first thing. So let's go from left to right because you know your vertical shift is last and it's on the outside. So going from left to right, the first thing we're going to go over is this negative right out here, right? And remember, when we have a negative outside, we have a reflection over the x-axis. So outside x-axis. Reflection over the x-axis. So that's the first thing we're going to do. We're going to reflect it in blue to identify with our color that we selected that. The next thing we're going to do, now that we've reflected over the x-axis, we just boom, flip it. We're going to keep going from left to right. And now we're going to see that we have something inside, and we have a positive 2. So if you guys remember, when you have a positive 2 inside, that means that we have a horizontal shifts, because horizontal shifts are inside, and it's inside, so it's opposite. You think plus 2 is to the right, but it's not. It is 2 units to the left. Okay? So now we're going to shift this function 2 units to the left. We're going to make this color right here. Let's make it green. So if I go 2 to the left, I'm just going to draw the same shape. But I'm going to the left. Okay? Now I'm going to do one last touch, and that is when I check out, still going from left to right, I have one last thing, and it's going to be this vertical shift here of -1. So negatives are the same. They're not opposite like horizontals. They're the same. So if I have a -1, I'm just going to go 1 down. And I'm just going to go 1 down. So it looks like it's almost in the same place, but the green is on the axis, and the red is actually right under it. So if I draw the green a little better, our green goes through the axis, while the red is just 1 down, not through the axis. All right, so we have shifted it 1 down. So now we can see all the shifts that we can go from left to right. We first reflect over the x-axis, we move it 2 to the left, and 1 down. And always do vertical shift last. Okay, so now we're going to do example 2. So now in example 2, we start off the same way we do in example 1. We draw our parent function. Our parent function in this case, if we look out for our exponent, it's going to be our even function. Even functions go the same way. So it's going to look like a parabola. So this parabola is going to look like this in black. We're going to draw it in black. Okay? So after we draw it in black, we're going to start looking from left to right. And we're going to be like, okay, we have a 2. So a number outside, let's draw it in blue, so then we can match it to its color. So a number outside is going to affect it's going to affect our function, transform it vertically. But a number outside, it's a number, right? And it's a vertical stretch outside. Numbers outside are vertical stretches. So when you have a number, it's going to make you skinnier. Vertical stretch is going to make it skinnier. So we're going to make your parabola look skinnier. See, here we don't really care exactly how much skinnier it is or how much fatter it is. We just care about making it look distinctly skinnier compared to fatter. You know, like you can tell that the blue is skinnier than the black. So now that we have drawn the transformation of the 2 that makes it skinnier, now we're going to keep going to the right. So now we're going to change to our color green, and we have a -1. Once again, a -1 inside. Inside you have a horizontal shift, but horizontal shifts they're opposite. So instead of going -1 to the left, we're going to go 1 to the right. So we're going to shift your parabola 1 unit to the right. Remember, these things are every 2, so it's like between the first dash and the origin. So 1 unit to the right, and we're going to draw a skinny looking parabola. Alright? And now we're going to do our last, we're going to keep going to the right, and we're going to do our last shift, which is always a vertical. And we're going to have here our -4, which -4 in a vertical is going to go 4 down. It's outside, it goes 4 down. So now you still go down your green function, down here. Okay? So you have gone through every transformation now, and we have finished example 2. Now we're going to go through a little bit of matching. I'm just going to give you guys the equations, and I'm already going to give you the graphs, and we're just going to discuss how they're going to match, right? So they're obviously going to be like not obvious answers, but you're going to have to know what's going on. So let's start with the first one. How we're going to do this is we're going to start with this one right here, and we're going to find the letter, and then we're just going to put it right in here, right? So the first thing we got to know about our function here. These are all penis functions, right? I told you guys I love a penis function. So the original function is they're all going to look like this, right? So we have our penis function, and now we're going to start from left to right, seeing the shifts, right? So we have a fraction outside of our penis function. So this is considered a fraction, so it's considered a vertical shrink. You guys just look up on the top of the page. You guys will see that when you have a fraction, it becomes a vertical shrink. So a vertical shrink means that instead of going up, instead of stretching your penis up, you're stretching it, you're kind of like shrinking it, right? So you can have like a fatter penis in a way. So you're going to go from here, you're going to shrink it down. So you're shrinking your penis. And then you have a negative inside, right? So when you have a negative inside, that is a reflection over the y-axis. You have a reflection over the y-axis now. So now you're going to reflect your green penis here over the y-axis, shrunk, vertically shrunk. And the last thing you're going to do is going to be your vertical shift. So now you're going to shift your penis. Let's put it like in black or something so we can see the difference. We're going to shift it 2 up. So shift your penis 2 up, right? So now we're going to ask ourselves which function looks like this. So it needs to be a penis facing this way to the left, and when we look at it, this one's A is facing to the right, B is facing to the left, and it is shifted 2 up. You guys see how B is shifted 2 up and facing to the left. Okay, we're good. We select B, and we have finished the first one. So that's how we're gonna get, and that's how we're gonna get through the rest. So pretty much now we go to the second one, right? So the second one has no number multiplying to it. So let's just draw a regular penis in blue. Start with a blue penis. And now we're going to nothing outside, so we don't care about it. Now we go inside, and by outside I meant in front of the function, not outside as vertical. So now we have inside, we have a +2. So when we have +2 inside, we're going to go the opposite direction horizontally. So a +2 inside is not going to go to the right 2, it's going to go to the left 2. So now we're going to shift, let's make it a green. Actually I made it blue, so let's just stay to blue. So we're going to go to the left, same direction, just exactly the same, just shift it to the left. And now we're going to throw in green, we're going to throw in this -1 in green, and we're going to move it 1 down. Same direction, just 1 down. Okay, so now we look through A. A is facing, this penis is facing up like this. A is facing down, it's having a bad day. So A is not working out. B is already chosen, so no B for this guy. How about C? C moved to the left 2 units and 1 down. So hey, C is our winner. So C is our winner for the second one. Now for the third one, let's again start off with our penis. And then we're going to start off from left to right. So that means that we have a -3 here. So the -3 actually has 2 things going on. We have a negative and we have a number. So let's start out with the negative, which comes before the number. The negative is going to shift my function over the x-axis, not the y-axis. Remember, a negative outside is over the x-axis. So we're going to shift your penis. Looks like I moved it down, but I didn't move it down. I'm just going to shift it. I'm going to reflect it over the x-axis. Boom. And now I am going to apply that factor of 3, which if we have a number outside is a vertical stretch, so skinnier. So my penis is gonna grow, but let's make it green. So let's leave it up black. So now it's gonna grow. We're gonna stretch that black thing a little lower. Sounds wrong. I'm sorry. So then in green, we're gonna keep going to the inside. So we have a -2. So that means we're gonna move it 2 to the opposite direction. So we have -2. You think it's left, but opposite direction is -2. So it's 2 to the right. So we're gonna draw it like kind of like this over here, and then we look for vertical shifts, but we have nothing adding outside or subtracting outside, so we have no vertical shifts. So now we look in our options between A and D for something that looks like our green penis. So if we look at A, it's shifted 2 to the right, and you guys see how it's just facing this way. So we may think it's not at the axis, but this guy is actually just coming like this, and looks the same direction that our green penis looks like. Therefore, our answer is A. Because it is facing the right direction, because it's being reflected in the right direction. You see how it's a little steeper. It's just like boom, and also it moved 2 to the right. So we're left with, for the last one, we're left with option D. But let's say we were to compute it as well. Let's see what we would get. And there's something very important about this example that we have here, because when you look at it, you want to do this separately, right? You want to do this, you want to jump right into it, and you want to just say, okay, we have a negative inside, right? So I'm going to grab my penis, I'm going to reflect it over the y-axis because that's a negative inside, and I'm going to shift it to in the opposite direction. So I'm going to shift it to the left. Okay? So you want to do that. But guess what? That's not our graph. And here's the problem. The problem for that being is that whenever you have a negative inside of a radical specifically, which is most of the cases, whenever you have a negative inside, you need to factor out your radical. You need to factor out your radical. And what I mean by that is factor out the negative instead of the radical. So you're going to get x, you're taking away a negative from the x, so it becomes positive x, and you're taking away a negative from the positive 2, so it becomes a negative 2. So actually when you look at it now in the blue, you actually have a vertical reflection over, a horizontal reflection over the y-axis, and you're also going to have a shift 2 to the right. So you're not just moving to the right 2, you're not just moving to the left 2, you're moving to the right 2, because when you take out that negative, it matters. So we're going to eliminate this. And you see how now our function is shifted to the right. And I apologize for this, but my answer has an extra negative out here, because I also reflect it over the x-axis. I don't only reflect it over the y-axis and get it shifting that way, going that way, but I'm also going to reflect over the x-axis. I apologize for the missing negative. Okay? So then we can see that our answer for this one is D. So we have two reflections here. We have a vertical reflection and we have a horizontal reflection. Now it doesn't matter which one you do first. All that matters is that you do your vertical shift last, which in this case we didn't have any, so nothing to do there. So now we've done all the transformations you guys can be able to get, and we're going to do some practice problems right after this to make sure you guys get it. So I'm going to throw everything in together at the same time: vertical, horizontal shifts, reflections, stretches, whatever it has to be, to just make sure that you guys can put it all together. Because separated, it can be pretty easy, but when you put it all together, it can get pretty tough. So let's get started.